Hi, we welcome that feedback. Neil Haggath graduated from the University of Leeds in 1983 with an honours in physics in astrophysics. The software engineer
Not anymore.
The last one is astronomy and spaceflight. Born in 1961, a few months after Young was on the flight, so it's fair to say it's all with the space age. The entire time here is space training of the space race and the Apollo program. The result of fascination is the space flight is development. He's been an amateur astronomer since as early age as he can remember, and a member of the Cleveland and Darlington Astronomical Society since 1981. He is very proud to be a fellow of the Royal Astronomical Society, having been elected to that honour in 1993. So put your hands together and let's welcome Neil.
Thanks, Roy. So, can everybody hear me online?
Right, thank you, Meg.
Just one correction, Roy, in the introduction. I'm no longer a software engineer by profession because I'm now retired, as of a few months ago. Yeah. It's a long story. Right. You couldn't make it up. This talk is a bit unconventional. Instead of talking for an hour on a single topic, I'm going to tell you a collection of short stories from the history of astronomy, which are unfortunate, bizarre, or just daft. And I have to say at the start that I'm not in any way prejudiced against the French, honest, but they do feature rather prominently in several of these tales. Right, before I start on the actual stories, I'll briefly mention an assortment of unfortunate or embarrassing things that people have said in the past. Yeah, no, like so. Many cultures had superstitions about comets. They were thought to be evil omens and to foretell wars, natural disasters, and especially the death of kings. For example, the comet we now call Halley's appeared in 1066 and is depicted in the Bayeux Tapestry as being a warning to poor old King Harold. But given the nature of human history, you can find a war somewhere or some sort of disaster for just about any year you care to think of. One of the names for comets in ancient times was hairy stars. In fact, the word comet is derived from the Latin word for hair. At another apparition of Halley's in AD 79, the Roman Emperor Vespasian wasn't worried and claimed that it menaces rather the king of the Parthians, for he is hairy while I'm bald. But Vespasian died later that same year. Even the most respected people are sometimes prone to say daft things. We're all familiar with meteorites. There have been legends of stones falling from the sky for thousands of years, but the idea wasn't taken seriously by scientists till the end of the 18th century. The first scientific proposal that meteorites come from space was published in 1794, but was widely ridiculed. Then in 1803, a meteorite shower of over 3,000 fragments was seen to fall on a town in France, and Jean-Baptiste Biot, who investigated the event, wrote a paper which pretty well established the stone's origin. But 4 years later, when a couple of American scientists wrote about the subject, the extremely respected President Thomas Jefferson said, quote, "I could more easily believe that two Yankee professors would lie than that stones would fall from heaven." An American president refused to accept the truth. Who could have imagined that? In 1830, the eminent French philosopher Auguste Comte cited the chemical composition of the stars as an example of something that could never possibly be known. But only 29 years later, Kirchhoff and Bunsen explained the absorption lines in the sun's spectrum and related them to several elements. Then in 1863, Sir William Huggins identified elements in the spectra of Betelgeuse and Aldebaran, showing that we can indeed know the chemical composition of the stars. Even more embarrassing was the statement by the American astronomer Simon Newcomb in 1903 that in the current state of science and knowledge, building a heavier-than-air flying machine was impossible. He wrote that just 2 months before the Wright brothers made the first flight, and his paper went into print after the event. But for something really silly, let's go back a few centuries again. In 1572, a new star appeared in the sky, which became so bright as to be visible in daylight. We now know this was a supernova, but obviously in those days nobody could possibly explain it. The great Danish astronomer Tycho Brahe studied it in detail, and it became known as Tycho's star. Part of its historical significance is that it challenged the prevailing religious dogma that the heavens were perfect and unchanging. In those days, even the intelligent believed in astrology, and many, including Tycho himself, believed the star to have some great astrological significance. Queen Elizabeth I consulted an astrologer about it, but what she was advised isn't known. But the most bizarre interpretation was that of one Georg Bush, who claimed the star was formed by the ascent from earth of human sins and wickedness, and said, this poisonous stuff falls upon people's heads and causes all kinds of unpleasant phenomena, such as diseases, sudden death, bad weather, nets, and Frenchmen. As Sir Patrick noted, what the French thought about this is not on record. Now we get to the first of the actual stories. The Catalogue of the Unwanted. If I was to mention M42 to you, most of you would know what I mean. The Great Orion Nebula, of course, and M31, the Andromeda Galaxy, and so on. The M, of course, stands for Messier. Almost all amateur astronomers are familiar with the Messier catalogue, the first list to be compiled of what we now call deep sky objects. It contains 109 objects, though they're numbered up to 110. The object listed as M102 doesn't exist and is believed to have been listed erroneously. Observing all of them is often regarded as a rite of passage for amateur astronomers. The catalogue was compiled in the 18th century by a Frenchman, Charles Messier, who observed in Paris with a 4-inch refractor. But the story behind it's a bit strange. While modern observers use the catalogue as a list of interesting objects to observe, Messier compiled it for the exact opposite reason. Not because he was interested in those objects, but because he wasn't. His primary interest was hunting for comets. Then, as now, comets were named in honour of the discoverer, so discovering one was a way of immortalising your name, especially if you were lucky enough to find one that became bright and well known. So many observers, as is also still the case today, systematically searched the sky in the hope of finding a new comet. Messier was no exception. He did, in fact, discover 13 of them, though none of them became very bright or spectacular. But while searching for comets, he often came across various faint, fuzzy objects, which he initially mistook for comets, then realised they weren't. Some of these turned out to be clusters of stars, others what we now call nebulae. The concept of galaxies, of course, wasn't yet known, so they were also classed as nebulae. A few such objects, such as the Pleiades, are visible to the naked eye, and so have been known since ancient times. A handful more had been discovered before Messier's time, but no one had paid much attention to them, and nobody knew what the nebulae were, apart from fuzzy smudges. The word nebula comes from the Latin for cloud. As Messier was frequently distracted by these objects, he decided to compile a list of their positions and descriptions, simply to avoid wasting his time when he happened to chance on them again in future. And he later published his list so it could serve the same purpose for fellow comet hunters. For that reason, he included a number of objects discovered by other people who had informed him, as well as his own discoveries. The initial version of the list, titled Catalogue des Nébuleuses et des Amas d'Étoiles, Catalogue of Nebulae and Clusters of Stars, was published in the Memoir of the Académie des Sciences in 1774. That was the French equivalent of our Royal Society, and it contained 45 objects. Over the next decade, he published several supplements, increasing the number to 103, though 102 was found to be an error. The final version was published in the French almanac Connaissance des Tombes in 1784. Next. Despite his lack of interest in the objects, he did actually produce sketches of some of them, as well as written descriptions. Next. This is his drawing of M42, the Orion Nebula. That's not bad for the 18th century, is it? Only about half of the objects in the catalogue were discovered by Messier himself. his friend and protege, Mishaps, discovered 25 of them, and the rest were discovered by a number of other people. Strangely, before the final version was published, Mishaps had acknowledged that his own discovery of M102 was an error, probably a repeat observation of 101 with a mistake in recording position. But for some reason, it wasn't removed from the catalogue. In 1921, Camille Flammarion found a handwritten note in Messier's own copy of the catalogue, which indicated that he'd observed the object we now call the Sombrero Galaxy and proposed that it be numbered M104. Between then and 1968, 3 historians found evidence that either Messier, Mishaps, or both had observed another 6 objects, so the catalogue was extended up to 110. When we see some of the Messier objects today, we may well wonder how anyone could possibly mistake them for comets. But we have to remember that telescopes in Messier's day were relatively crude compared to what we take for granted. But it's still hard to imagine how anyone could have mistaken the Pleiades for a comet. At about the time the final catalogue was published, Sir William Herschel, perhaps the greatest visual observer who has ever lived, began building ever bigger telescopes and began his own search for deep sky objects. Unlike Messier, he was interested in those objects in their own right and wanted to investigate their nature. Over the next 20 years, he discovered an amazing 2,500 of them. His son, Sir John, during his 5 years in South Africa, extended the catalogue to cover the southern hemisphere of the sky, where he discovered another 1,754 objects of his own. Together, their catalogues would later form the basis of what we now call the New General Catalogue, the NGC. But Sir William deliberately didn't assign numbers in his own catalogue to the objects listed in Messier's. It's rather ironic that while Messier did excel at his chosen pursuit of finding comets, we remembered him for his catalogue of objects he wanted to avoid. Messier is buried in the famous Père Lachaise cemetery in Paris, along with many of the great and the good of France, but sadly his grave has been neglected and fallen into a state of disrepair, such that even his name is barely readable anymore. I went there in 2015. From reading someone's description, I knew roughly where the grave was to within about 100 meters, but I wasn't able to identify it. But thankfully, in the last few years, a French campaign group has raised funds to restore it and added a new plaque. Next. Planet that wasn't. I'm sure most of you have heard of this one. This is the story of one of the most bizarre episodes in this history of astronomy, the discovery of a non-existent planet. The story involves an unlikely combination of characters, one of the most eminent astronomers and mathematicians of the era, and an obscure amateur whose enthusiasm, shall we say, exceeded his ability. First, a little background. The planets out to Saturn have been known since ancient times, though of course it wasn't until the 17th century and the invention of the telescope that anyone realised that the wandering stars were worlds like our own. The first planet to be discovered in recorded history was Uranus, found by pure chance by Sir William Herschel in 1781. At this point, I can also mention the discovery that wasn't. Before Uranus was discovered, we could never know how many people might have actually seen it without realizing what it was, as through a small telescope it would have just looked like a star. But from examination of preserved observing logs, 4 different people are known to have observed it on a total of 22 occasions before 1781, and so missed out on a place in history. The first was John Flamsteed, the first Astronomer Royal, who recorded it as a star in 1690, 91 years before its discovery, and gave it a number in his catalogue. He later recorded it another 5 times. While it would have been indistinguishable from a star with a small telescope, you would think that if a diligent observer happened to see it multiple times in a period of weeks, he would have realized that it was moving with respect to background stars. But one Pierre Lemonnier, another Frenchman, wasn't very diligent. He was found to have observed it 12 times in total, and in December 1768 and January 69, he did so 8 times in 4 weeks, without realizing that it was anything other than a star. To quote Sir Patrick again, he was not blessed with orderly mind. He certainly didn't keep orderly records. One of his observations was found scrawled on a paper bag. By the 1840s, it was clear that Uranus wasn't behaving quite as it should. Its position in the sky deviated from that predicted by the calculations of its orbit. Two mathematicians independently concluded that its orbital motion was being perturbed by another planet even further from the Sun and as yet unseen. They even predicted where in the sky the new planet would be. One of these was a young Englishman, John Couch Adams. He sent his calculations to the Astronomer Royal, Sir George Airy, but inexplicably nobody thought to follow up the matter and initiate a search till it was too late. The other was a French aristocrat, Urbain Jean-Joseph Leverrier, who would later become director of Paris Observatory. Using his calculations, a number of people across Europe searched for the hypothetical planet. In 1846, Johann Galle and Heinrich d'Arrest at Berlin Observatory found it in almost the exact position predicted by Leverrier. In fact, I think they actually found it on the first night of looking. It was, of course, the planet we now call Neptune. Leverrier's prediction was hailed as a great triumph for Newtonian physics. It turned out that Adams had actually done the calculations first, and a diplomatic dispute ensued between Britain and France over who should be given priority for the prediction. But as Leverrier hadn't known about Adams' work, and it was his calculations that Galle and the rest had used, they are rightly given the joint credit. And in fact, Adams himself said that Leverrier deserved it, as it was his calculations that were used. Leverrier is the first of the two central characters in our story. While he was a brilliant and highly respected mathematician and astronomer, his qualities as a human being were somewhat less admirable. He was arrogant, irritable, and bad-tempered, and was described by one contemporary as the rudest man in all of France. In 1870, he was forced to resign as director of Paris Observatory due to his bullying manner, though he was later reinstated following the premature death of his successor. Following his success in predicting the existence of Neptune, Leverrier turned his attention to another problem that was puzzling astronomers concerning the orbital motion of Mercury. Mercury's orbit is somewhat more eccentric or elongated than those of the other planets, and the direction of the long axis of the ellipse rotates or precesses over long periods of time. This phenomenon, called perihelion precession, is predicted by classical Newtonian orbital dynamics, but the rate of precession wasn't right. The measured rate was nearly double that predicted by theory. Perhaps not surprisingly, Leverrier proposed that the discrepancy was due to the presence of yet another unknown planet closer to the Sun than Mercury. His prediction was widely publicized. Many other astronomers agreed and initiated searches for this latest hypothetical planet. They even gave it a name, Vulcan, after the Roman god of fire. But for some years, they could find no sign of it. We now know that the true cause of the discrepancy is something that Leverrier and his contemporaries couldn't have worked out. It's a consequence of Einstein's general relativity, which still lay more than 60 years in the future. Had Vulcan existed, it would obviously have been near impossible to see in normal circumstances, as it would have been permanently lost in the sun's glare. Think about how difficult Mercury is to see. It was proposed that there might be two ways of finding it. One was that it could be seen during total solar eclipses. The other was that it would periodically transit the sun, as Mercury and Venus do. Transits of Mercury are fairly common, occurring about 13 times per century. Those of Venus, as we all know, are much rarer. Skeptics pointed out that astronomers had been regularly observing the sun for 2 centuries, and no such transit had been observed. This would suggest that if Vulcan existed, its transits must be extremely rare. But simple geometry said that they should occur more frequently than those of Mercury, unless the planet was in a highly inclined orbit, which itself was highly unlikely. Now enter the second of our central characters. Dr. Edmond Lescarbot was a modest, unassuming, but somewhat eccentric country doctor and amateur astronomer who lived in the village of Auger-en-Beauce, southwest of Paris. He wasn't very well off. Legend has it that he couldn't afford writing paper, so he wrote his observing notes on a plank of wood, later planing off the surface to use again. But he had built an observatory and owned a 95mm refractor, though of what quality we don't know. One of Lescarbault's interests was observing the sun. On 26th of March 1859, he observed a small black spot apparently moving across the face of the sun. He was familiar with transits of Mercury, having observed one in 1845, but knew there wasn't one due. He concluded that what he'd seen must be Leverrier's predicted planet, Vulcan. Yet, for some reason best known to himself, Lescarbault shied away from informing anyone of his observations for the next several months, probably afraid of being ridiculed. But finally, in December, he plucked up the courage to write to Leverrier in Paris. Despite his conviction that Vulcan existed, Leverrier found it hard to believe that an unknown, modestly equipped amateur could have succeeded where so many more proficient observers had failed. But to his credit, instead of dismissing the claim out of hand, he decided to investigate. So he travelled to Alger to interview Lescarbault in person. When the great man, arrogant and overbearing as he was, arrived unannounced at the home of the mild-mannered doctor, what followed has passed into astronomical folklore. Poor Lescarbault couldn't have known what had hit him as he opened his door to be greeted by, "It is then you, sir, who pretend to have discovered the intramercurial planet and who have committed the grave offence of keeping your observations secret for 9 months. I warn you that I have come here with the intention of doing justice to your pretensions and of demonstrating that you have been either dishonest or deceived." But amazingly, despite such an unpromising start, Leverrier actually became convinced that Lescarbault had made the first observation of Vulcan. On the 2nd of January 1860, he announced the discovery to a meeting of the Académie des Sciences, French equivalent of Britain's Royal Society. Lescarbault, for his part, was made a Chevalier du Légion d'Honneur, France's highest award, and invited to appear before learned societies. Over the next few years, other observers announced supposed observations of Vulcan, and Leverrier used them to calculate an orbit for his planet. He concluded that it orbited at only a third of Mercury's distance from the Sun. Others became more and more sceptical. Some examined records of solar observations from the day of Lescarbault's transit and found nothing. Careful observations were made during a total solar eclipse in 1878, a year after Leverrier's death, but there was no sign of Vulcan. By that time, most astronomers had concluded that it didn't exist after all, but Leverrier refused to budge. Until the day he died, he remained convinced that his planet was real. Lescarbault himself finally ended the fiasco by driving the final humiliating nail into the coffin of his own credibility. In 1891, he announced to the Academy that he'd observed a new star in Leo, which turned out to be Saturn. The doctor was just not a very competent observer. We'll never know what he actually saw, but his transit of Vulcan was probably nothing more than a big sunspot, or maybe even due to a defect in his telescope. But the real mystery is how such an accomplished scientist as Leverrier came to be fooled. Probably his arrogance was his downfall. His unshakable belief that his own prediction couldn't possibly be wrong led him to be taken in by Lescarbault's delusion. He really should have known better. Unlike poor Messier, Leverrier seems to be much better remembered beyond the field of astronomy. He's buried in Montparnasse Cemetery in Paris, and this is his grave next. Photographed by me in 2015. Now, I wonder if anybody knows what this one's about. Do keep quiet. The Heavens and Mrs. Hodges. One of my favourite obscure quiz questions, which very few people ever get, is what was the claim to fame of Mrs. Ann Hodges of Sylacauga, Alabama? This is the story of how an ordinary American housewife earned a place in astronomical history just by being in the wrong place at the wrong time. Anne Elizabeth Hodges was the first human being in history known to have been hit by a meteorite. It remains the only reliably documented case, though there have been a couple of others claimed in more recent years. On the 30th of November 1954, at 2:46 p.m. local time, a fireball was seen over Alabama. The object broke up into many fragments, some of which hit the ground in and around the town of Sylacauga. The biggest chunk, weighing 3.9 kilos, crashed through the roof of a house and hit poor Mrs. Hodges, who was having a nap on a sofa. Thankfully, though the meteorite had been falling at its terminal velocity of around 200 kilometers an hour, most of its kinetic energy must have been dissipated in its impact with the roof. Mrs. Hodges survived and wasn't seriously injured, though she was left with a belt of a brood. That is, she didn't suffer any serious physical injury, but she had psychological problems for years afterwards and seemed to have suffered from what we would now call PTSD. The sad part of the story is what happened afterwards. Mrs. Hodges made a modest amount of money by selling a story to the papers and appeared on a TV game show called I've Got a Secret. But she missed out on a hell of a lot more. After a geologist examined the rock and identified it as a meteorite, it was sent to the Smithsonian for analysis and was later returned to the Hodges. Generally speaking, if a meteorite falls on your property, then you legally own it. So you'd imagine that Mrs. Hodges would have at least had the consolation of being able to sell a nemesis, which even in those days would have been regarded as pretty valuable. Unfortunately, she and her husband Eugene did own the home, but only rented it. So the meteorite legally became the property of their landlady, one Mrs. Guy. The latter claimed she needed the money to repair the house. Because, surprise, surprise, her insurance refused to pay out, presumably they invoked the ridiculous so-called act of God clause. But not surprisingly, public opinion sided with Mrs. Hodges. A bitter legal dispute ensued, which went on for over a year, before Mrs. Guy gave in and sold the meteorite to the Hodges for a modest sum. By then, interest had waned, and the Hodges amazingly couldn't find any museum or institution willing to buy it. They turned down a modest offer from the Smithsonian in the hope of getting better offers, which never came. Believe it or not, they used it as a doorstop for a while, before eventually donating it for free to the Alabama Museum of Natural History, where it remains to this day. Another piece of the meteorite, less than half the size of the Hodges, was found on the land of a neighbouring farmer, and he was able to buy a new house and a car with the proceeds. So the Hodges piece, with its unique heritage, should have been worth a substantial fortune. That they ended up with nothing defies belief. If only they and Mrs. Guy had just come to a friendly agreement to share the proceeds, all of their lives might have turned out very differently. In 1992, in New York City, a small meteorite hit a parked car. As the car was an old banger, it was a write-off. The car belonged to a 17-year-old student who had bought it for $500. She was able to sell the meteorite for $50,000 and the car to a museum for another $25,000. So had Miss Hodges' story occurred in the present day, she'd probably have made many times that sum. Mrs. Hodges suffered health problems later in life and died in 1972, aged only 52. It's impossible to say whether a unique experience and the resultant stress was a contributing factor. Next. Ungentlemanly conduct. We astronomers would like to think we're generally a pretty friendly and civilized bunch of people, especially towards each other. I have friends in many parts of the country among the astronomy community. Some of them have been my friends for 40 years or more, including some in this room. But of course, there are a few exceptions. There have been a few cases of eminent astronomers who really didn't get on, and even some who engaged in outright hostilities. Reverend John Flamsteed, the first Astronomer Royal, intensely disliked his assistant and successor, Edmund Halley, whom he said drank like a sea captain and swore worse. They had a bitter dispute over the publication of Flamsteed's star catalogue. The Royal Society lost patience with waiting for Flamsteed himself to publish it, and Halley did so without his consent. Flamsteed responded by buying 3/4 of the printed copies and burning them. Around the same time, there was certainly no love lost between Sir Isaac Newton and the physicist and polymath Robert Hooke. Hooke had a number of ideas, including about gravity, which preceded Newton's work, and he later argued about priority and practically accused Newton of stealing his work, which he didn't, as Sir Isaac clearly acknowledged Hooke's contributions in the Principia. Then, of course, there was Leverrier, whom I talked about a few minutes ago, who just didn't get on with anybody. In the 20th century, we had Fritz Zwicky, who died 51 years ago. He was one of the great geniuses of modern astrophysics. He predicted neutron stars, dark matter, and gravitational lensing, all decades before they were confirmed to exist. But he was notoriously grumpy and difficult to work with. It says something about him that the most famous image of him next is this one. And his temperament was probably a factor in him never truly getting the recognition he deserved. Neil deGrasse Tyson described him to TV viewers as the most brilliant man you've probably never heard of. He also had a colourful turn of phrase. His favourite insult for colleagues he really didn't like was spherical bastards, meaning you can look at them from any angle and they're still bastards. And I've worked with and for quite a few people who I could apply that term to, including my last job, where I worked for a prime bunch of them. But for the feud to end them all, we go back nearly 2 centuries to the story of 2 English gentlemen who behaved like anything but. In 19th century Britain, there was a class of astronomers whom Alan Chapman called the Grand Amateurs, wealthy gentlemen of leisure who didn't need to work and were able to devote themselves to the hobby on a grand scale. Some of these made their fortunes in business, then retired early. Others were either born into wealth or married into it. Our 2 characters here belonged in the latter 2 categories. The first was Sir James South next. He came from a fairly well-off family and trained as a surgeon. But at the age of 31, he married a very wealthy heiress and was able to give up work and devote himself to astronomy, building an impressive private observatory in Kensington. In his 30s, South became very well respected as an astronomer. One of his friends was the young John Herschel, son of the great Sir William, who became a very eminent astronomer in his own right. They collaborated on an extensive study of double stars and greatly improved on Sir William's catalogue. After all, Sir William had to make do with homemade telescopes and nothing like the precision instruments available to the next generation. His friends also included the young George Airy, who would later become the longest-serving Astronomer Royal, and Sir William Parsons, the 3rd Earl of Ross, who would later build the world's biggest telescope. He was a meticulous observer and one of the first to realise the importance of recording the uncertainties in measurements as a measure of reliability. But he wasn't very good on theory and maths. But for his skills as an observer, he was elected a Fellow of the Royal Society in 1820. In that same year, he's one of the founders of the Astronomical Society of London, as it was originally called. He served as its president from 1829 to 31 and was instrumental in getting the Society's Royal Charter, whereby it became the Royal Astronomical Society. He was given the highest awards of both societies and was knighted by King William IV in 1831. But there was another side to South. As a man of independent means, he wasn't afraid to speak his mind or afraid of offending people, and was prone to making scathing criticisms of people with whom he disagreed. As one of the founders of the RAS, it was considered only right that he should have a turn as president, but some had reservations, as he'd already acquired a reputation for being opinionated, stubborn, and difficult. So it was decided to appoint as secretary a man who was guaranteed not to be intimidated by him. That man was the Reverend Richard Sheepshanks. He'd been born into a wealthy Yorkshire family. He was both a Church of England clergyman and a qualified barrister, but his inheritance enabled him to give up both and devote his life to astronomy. He was also highly respected in the RAS, but was also opinionated, sarcastic, and like South, spoke his mind without regard for the consequences. He was appointed secretary to, in quotes, keep the president in order, and he relished the role. Sheepshanks already disliked South at this time and was scathing about his lack of mathematical ability, saying that Sir James doesn't know a sine from a cosine and isn't able to use a table of logarithms for the simplest computation. He later wrote that South knew nothing and was well aware that he knew nothing, and he knew that I had no difficulty and not much scruple in setting him right when he got out of his depth, which was very often. Hardly surprisingly, putting the pair of them together like that brought out the worst in both. It's fair to say that there wasn't a meeting room big enough for both their egos, and the personal animosity would last nearly 3 decades. After the end of his presidency, South resigned from the Council of the RAS, but Sheepshanks, having questioned his mental state, among other things, was largely responsible for hounding him out. In 1829, South achieved something quite remarkable. The renowned optician Cauchois of Paris had made what was then the world's biggest achromatic objective lens, 11 3/4 inches aperture and 19 feet focal length, and South managed to buy it. It cost him £1,000, equivalent to something like 100,000 today. He commissioned the renowned instrument maker Edward Troughton to build him what would be the world's biggest and finest refractor. Troughton was 75 by then and had formed the company of Troughton and Sims with his younger business partner, William Sims. He previously built an excellent but much smaller refractor for South of 3 3/4 inches aperture and 5 feet focal length with an equatorial mount. Equatorial mounts were in their infancy in those days, the first one having been built by Joseph von Fraunhofer just a few years earlier for the 9.5-inch Dorpat refractor in Estonia, which was then the world's biggest, which still exists as a museum piece. Troughton's mount was a prototype of what became known as an English equatorial, whereas Fraunhofer was what called a German equatorial. South, who knew nothing about engineering, wanted him to build a bigger mount of the same style, but Troughton, who was yet another stubborn and difficult character, accustomed to getting his own way, believed that a simple scaling up wouldn't be stable enough for the much bigger and heavier telescope, and he insisted on designing a completely new type of mount. South initially trusted his judgment, but there was trouble brewing. By May 1831, South had lost all confidence in Troughton. The work was long behind schedule and several times over budget, and he was so worried about the mount that he offered to reimburse all Troughton's expenses so far if he'd agreed to abandon it and start again with a scaling up of a smaller mount. Troughton refused and South dismissed him, even though Troughton had already incurred 90% of his expenses. Troughton had also had to work with a major handicap. South refused to let him or his workers handle the precious lens, so they had to build the telescope without the objective in place and therefore hadn't been able to test it. In December, the telescope was finally put in place and defects were immediately found. The mount suffered an unacceptable degree of vibration. Troughton came back and tried to rectify it, but without success. In May 1832, South wrote an angry letter to Troughton and Sims, demanding that he convert the useless mass into an equatorial worthy of yourselves and of my observatory. He even travelled to Estonia to see the Fraunhofer refractor, to see how its mount compared with his own smaller one. But strangely, whatever he learned, he didn't share it with Troughton, but he refused to pay Troughton and Sims for their work. At this point, enter Sheepshanks, who was a good friend of Troughton. He visited his friend and found the old man devastated. After reading the letters from South, he decided it was his duty to intervene. He wrote a legalistic letter on behalf of Troughton and Sims, saying that they had appointed himself and George Airy, soon to become Astronomer Royal, and who had fallen out with South, as advisors to try and resolve the problem. They were to be given more time to make modifications to the mount, and while Sims and the advisors were working, our proceedings shall be without witnesses or lookers on. So South was effectively banned from his own observatory. In the words of a later historian, Sims' task turned out to be hopeless, owing to the utter impossibility of getting South to listen to reason. South had stubbornly convinced himself that the telescope would never be satisfactory, and his relations with Troughton and Sims deteriorated into a prolonged legal dispute. While South is often portrayed as the belligerent old curmudgeon, it seems that he did actually have a strong case, and the intervention of Sheepshanks and Airy was really an attempt to salvage Troughton's reputation at his expense. Even Sims became exasperated at the attitude of his senior partner and had serious concerns about the mount. The situation dragged on for months. As some faults were rectified, others were found. June 1833, Sheepshanks advised Troughton to cut his losses and hand over completion to another company. Meanwhile, South put matters in the hands of his solicitors, but his legal position was at best precarious. There was no objective way of judging whether Troughton and Sims had done the job satisfactorily, as the contract had never specified any quantifiable standards of performance. In September, Sims declared that they'd done all that was possible and demanded payment for the work, which by then came to £1,235. South, of course, still refused. Sims then proposed that the matter should be settled by arbitration, scientific rather than legal. To determine the suitability or otherwise of the telescope, they proposed to appoint a number of eminent astronomers as judges. South's solicitors accepted this, and it looks as if reason might finally prevail. So several of the biggest names in English astronomy of the time were dragged into the dispute, but John Herschel managed to avoid getting involved as he was preparing to leave for South Africa. Troughton and Sims asked for a final few days to try to perfect the instrument at their own expense, but South refused again, as he realised that his own legal position would be stronger if the telescope was examined with its existing defects. Troughton and Sims, guided by Sheepshanks, then reneged on their own proposal of arbitration by astronomers and began legal action. In May 1834, the dispute went to court. Sheepshanks was the scientific advisor to Troughton and Sims, was also their legal counsel, in fact, if not in name. They were also supported by Airy, while South had scientific advice from his friend Charles Babbage, the man famous for building the first mechanical calculator. The arbitration involved an incredible 37 hearings over nearly 5 years, with most of the competent astronomers of the country supporting one side or the other. Meanwhile, a personal feud between South and Sheepshanks continued. South now saw Sheepshanks as his primary enemy, as he had orchestrated the legal proceedings. They publicly insulted each other through letters in the Times, till the editor refused to give them space anymore. By the time it was over, Troughton had been dead for 3 years, but the ruling finally went in favour of Sims. South was ordered to pay the bill, including a further £235 for improvements made by Sheepshanks and Airy, which South later described as spending for me an additional £200 in botching up with divers fooleries, a thing not worth as many farthings. But his legal costs came to several times that amount. Overall, he was left £8,000 out of pocket, equivalent to something like £750,000 today, while his observatory had stood unused for 7 years, and his huge investment in the Cauchoir objective hadn't resulted in a single useful observation. After this humiliating defeat, South's mental state appears to have deteriorated over the next few years to something approaching insanity. In the immediate aftermath, he decided that whatever the cost to himself, he would make a public display of his contempt for the mountain and all those associated with it. It's commonly said that he smashed up the telescope and mountain in a fit of rage and sold the parts for scrap, but that's not quite true. This actually took place in 2 parts. He did indeed dismantle the telescope, obviously preserving the precious lens, and demolished what he regarded as the useless mountain. To make it as insulting as possible to his enemies, he made a point of advertising the wood and iron parts for sale to the lowliest tradesmen. Mahogany doorknob, draw knob and ball turners, stool lucifer match, snuff box makers, and dealers in firewood and old iron. But he kept the brass components of the telescope, presumably with a view to reusing them in future. After his expenses, the sale actually made a loss. Not till another 3 years later, in 1842, did he finally give up on any idea of reusing the brasswork and again sold it for scrap. As for the valuable objective lens, another 20 years later, he gave it away to the University of Dublin. It was used in a refractor at Dunsink Observatory, which is still in use to this day. The poster for this second sale, which is the one usually cited, tells us a lot about South's mental state by this time. While the first had been deliberately insulting, this one bordered on deranged. Again, he offered the scrap for sale to the lowliest tradesmen, to shycock toy makers, smoke jack makers, mock coin makers, dealers in old metals, collectors of and dealers in artificial curiosities. But it was also addressed to such fellows of the Royal Astronomical Society as at the meeting of that most learned and equally upright body on the 13th of May last were enlightened by Mr. Airy's, the Astronomer Royal's, profound expose of the mechanical incapacity of English astronomical instrument makers of the present day. What was for sale was described as several hundredweight of brass, gunmetal, etc., being the metal of the great equatorial instrument made for the Kensington Observatory by Messrs. Troughton and Sims, the wooden polar axis of which, by the same artists, and its botchings cobbled up by their assistants, Mr. Airy and the Reverend Sheepshanks, were, in consequence of public advertisement, purchased by divers vendors of old clothes and licensed dealers in dead cows and horses, etc. And how about this bit? With the exception of a fragment of mahogany specially reserved at the request of several distinguished philosophers, which was to be sold on account of the great anxiety expressed by foreign astronomers and astronomical instrument makers to possess when converted into snuff boxes as a souvenir piquant of the state of the art of astronomical instrument making in England during the 19th century. The brass ended up being sold for 5p halfpenny a pound. Accounting for expenses again and the loss made by the first sale, South's total profit from both sales came to a whopping £11, 12 shillings and 9p against his £8,000 losses. Though he would live for another 25 years, this was the end of South's career as an astronomer. He continued to vilify his former opponents at every opportunity, prompting Airy to call him an ignorant blackguard no longer fit for the company of gentlemen. The only prominent friends who stayed loyal to him were Babbage and the Earl of Ross. The latter, in the 1840s, built his famous 72-inch reflector at Birr Castle, which was then the world's biggest telescope. South spent much of his latter years in Ireland with Ross and observed with him. The photo I showed of him earlier was taken by the Countess, but he no longer did any significant work of his own. There have been many personal feuds which only ended with the death of one of the parties, but that between South and Sheepshanks didn't even end there. In 1852, South and Babbage tried to get Sheepshanks expelled from both the RAS and the Royal Society. They brought up an episode from decades earlier in which Sheepshanks had committed an illegal act. It imported an instrument from France and had falsely inscribed the name of Troughton on it to pass it over the British and avoid paying duty. Sheepshanks admitted to this and said he was heartily ashamed. While the offence was pretty minor, South and Babbage argued that a man guilty of any criminal offence couldn't be allowed to remain a fellow of either society. Arguments dragged on and Sheepshanks died in 1855 before the matter had been resolved. As is customary, the RAS's obituary concentrated on his achievements and glossed over the unsavoury aspects of his character, of which there had been many. But South published a scathing criticism of the obituary, continuing to attack his former adversary even after he was dead. After one final response from Sheepshanks' allies, the 30-year battle was finally over. South is usually portrayed as the villain or loony in this story. In particular, the poster for the second scrap sale is often used to present him as a figure of absurdity. But for all his faults, Sheepshanks was at least as nasty as a character, if not more so, and neither comes out of it favourably. It was a tragedy for British astronomy in the mid-19th century that two such gigantic egos were on a permanent collision course. And of course, its greatest casualties was what should have been one of the world's finest telescopes. Next. And last but not least, I'll go right back to the 18th century to tell you the sad story of the man who was surely the unluckiest astronomer who ever lived. But first, we need some background again. At the beginning of the 17th century, when Galileo's observations provided evidence that the Earth is the centre of the universe and the planets orbit the Sun, Johannes Kepler, who was a great theoretician and is often described as the first astrophysicist, realised that the motions of the planets could best be explained by a model in which they orbit the Sun in ellipses rather than circles. In 1618, Kepler published his famous 3 laws of planetary motion, which were a forerunner of Newton's work on gravity. His 3rd law proved vital in measuring the scale of the solar system. Kepler's 3rd law states that the square of a planet's orbital period is proportional to the cube of its orbital radius. If the period is measured in years and the orbital radius has a multiple of that of the Earth, then the constant of proportionality is 1, and we can simply state it as next. P squared equals A cubed, where P is the period and A is the radius. It's a simple matter to measure the orbital periods of the planets by observation. So given that relationship, it's only necessary to measure the distance of one planet from the Sun, say the Earth, and then the distances of all the others can be deduced. By this time, the Earth-Sun distance, which came to be called the astronomical unit, or AU, had been measured by parallax methods to an accuracy of plus or minus about 3%. But in 1677, no less a person than Ed Halley realised how it could be refined. As we all know, both Mercury and Venus occasionally undergo transits, passing directly in front of the Sun as seen from the Earth. Transits of Mercury are fairly common. They occur about 13 times a century. But those of Venus are extremely rare. They occur only 4 times in every 243 years. Due to a quirk of orbital dynamics, which is beyond the scope of this talk, they always occur in pairs 8 years apart, with over a century between the pairs. So the majority of people never get to see one in their lifetimes. We've all been lucky enough to have a pair in ours in 2004 and 2012. The first person to realise that Mercury and Venus could transit the Sun was none other than Kepler himself. In 1627, he predicted that both inner planets would transit in 1631. But sadly, he didn't live to see them himself. He died the year before. The first transit ever to be observed was that of Mercury on the 7th of November 1631, which was observed by Pierre Gassendi in Paris. Nobody saw the Venus transit later that month, as it wasn't visible from Europe, and there weren't many telescopes, if any, outside Europe at that time. Kepler calculated that transits of Venus would be extremely rare, but he didn't realise that they'd occur in pairs. In 1639, Jeremiah Horrocks realised what Kepler had missed, that another would occur that year on the 24th of November, and that one would be visible from Europe. Horrocks made that discovery only a few weeks before the transit was due, so he didn't have much time to publicise it. It was observed by all of 2 people, Horrocks himself and his friend William Crabtree, but Horrocks wrote a paper on his observation. In 1677, Halley, during his famous voyage to St. Helena, observed a transit of Mercury. It then occurred to him that observations of transits could provide a method of refining the measurement of the AU. If a transit of Mercury or Venus was observed from 2 or more widely separated places on Earth, it would be seen in slightly different positions against the Sun due to parallax. If the event was timed very accurately, triangulation could be used to calculate the Earth-Sun distance with unprecedented accuracy. He soon realised that though transits of Mercury are much more common, those of Venus would be much more suitable. Mercury in transit through a small telescope appears as only a tiny black dot, and its ingress and egress are too quick to allow accurate timings. But from reading Horrocks' paper, Halley knew that Venus would appear as a distinct disk, and its motion would be much slower, so there'd be 4 distinct contacts that could be accurately timed, the ingress and egress of its leading and trailing edges. Halley's genius was matched only by his far-sightedness. He knew that the next pair of Venus transits wouldn't happen till the 6th of June 1761 and 4th of June 1769. But even though he himself wouldn't live to see them, he wrote a paper which he presented to the Royal Society to alert the astronomers of a future generation to their vital importance. This was followed by another paper written in Latin, which was distributed across Europe. Next. This simplified diagram shows the principle of Halley's method. Observers at different locations on the Earth would see Venus follow different apparent paths across the Sun of different lengths. The path lengths could be measured by accurately timing the contacts. Then, knowing the distance between the observers' locations, a bit of trigonometry would give the distance of Venus from Earth, from which the AU could be determined by Kepler's third law. When the time came, astronomers in Britain and France took up the challenge with a vengeance. In 1761, both the British Royal Society and the French Académie des Sciences organised a number of expeditions to diverse parts of the world to observe measurements of the transit from as many different locations as possible, and resolved to cooperate afterwards in analysing the data. This, of course, was in the days when intercontinental travel involved sea voyages lasting months, so the project was an enormous undertaking. But there was a major problem. Britain and France and their empires were at war at the time. That was nothing unusual around that era, but this wasn't just any war, it was the 7 Years' War, which was being fought across 4 continents and could justifiably have been called the First World War. The two governments, recognising the importance of the project, signed a treaty that supposedly guaranteed their transit expeditions safe passage through each other's territories. But this proved unworkable in practice. Some expeditions were caught up in fighting and some of the members were killed. Nevertheless, observations were obtained not only from across Europe, but also from North America, South Africa, and India. One heroic French team, led by Jean-Baptiste Chateauroche, even made a grueling overland trek to northern Siberia, where they had to fight off packs of wolves among other hazards. While the last transit of Venus had been observed by 2 people, this one was observed by some 120 astronomers from 62 locations on 4 continents. But after all that immense effort, the data proved of little use. It proved near impossible to time the contacts with the required accuracy due to an unforeseen problem that came to be known as the black drop. Despite the huge disappointment, the British and French astronomers resolved to try again in 1769. Now that they knew about the black drop, they could work out ways of correcting it to some degree to get more accurate timings. This time, they had to travel even further afield, as the transit was visible from the other side of the world, from Europe. But at least the war had ended by then, so the expeditions no longer had to worry about being attacked on the high seas. One British astronomer, Charles Green, sailed with Captain James Cook aboard the Endeavour. The primary purpose of Cook's round-the-world voyage, which led to the discovery of Australia, was to observe the transit from Tahiti. Sadly, Green died during the return voyage, but his results were brought back and contributed to the overall effort. This time, the data proved much more useful and eventually led to a determination of the AU that was pretty close to today's accepted value. So now we come to the unluckiest astronomer. The next time you're upset about an astronomical event being clouded out, spare a thought for this guy. One of the men dispatched by the French Academy in 1761 was an aristocrat, rejoicing in the sort of ridiculous name that could only belong to a French aristocrat. Monsieur Guillaume Joseph Hyacinthe Jean-Baptiste Le Gentil de la Galaisière. We'll just call him Le Gentil for short. He was an accomplished astronomer who discovered 3 of the nebulae in Messier's catalogue and had studied the Orion and other nebulae. He was sent to observe the transit from Pondicherry in India, which was in a French territory. He sailed from France in March 1760, so he should have had more than enough time to get there. But the war intervened. A few more minutes more, I think. He was delayed for several months in Ile-de-France, which is now called Mauritius. By the time he got to India, Pondicherry had fallen to the British. He couldn't take advantage of the Safe Passage Treaty as he was sailing aboard a warship. which was obliged to return to Ile-de-France. He was still at sea on the day of the transit. Though the sky was cloudless, it was impossible to make any observations from the deck of a sailing ship. Le Gentil was nothing if not determined. He knew the 1769 transit would also be visible from India, so he decided to wait for it. Instead of returning to France, he based himself in Ile-de-France and spent the next 8 years travelling around the Indian subcontinent, the Indian Ocean, and the Far East, where he carried out a remarkable variety of studies. Far from being the upper-class twit that his name suggests, he was in fact a highly respected scientist and quite a polymath. He mapped the coast of Madagascar and carried out research in geography, natural history, and anthropology. Come 1769, he made sure he arrived at Pondicherry again in good time. He could now go there safely as the war was over. In fact, he'd previously decided that Manila in the Philippines would be the best place, but when he arrived there, he wasn't made welcome by the Spanish government. I think there's big political disputes between Spain and France, so he was basically told to go away. So he went back to Pondicherry. He was made welcome there by the British governor, who not only offered to act as observing assistant, but also managed to obtain the loan of a telescope better than Le Gentil's own. The day of the transit began bright and clear, but guess what? Shortly before Venus made its first contact with the sun, it clouded over and then stayed that way. Poor Le Gentil didn't see a thing. And it hardly needs saying that it was clear in Manila. But our hero's troubles were only just beginning. During his years away from home, he'd forgotten about such niceties as writing to his family and to the academy. Or it could be that due to the war, any letters he did send never got there. His voyage back to France was delayed by a serious illness, storms, and a whole sorry saga of lesser mishaps. When he finally returned home in 1771, after more than 11 years away, he discovered that he'd been legally declared missing, presumed dead. His wife had remarried and his relatives had divided up his estate. When he suddenly turned up again, they conveniently failed to recognise him, denounced him as an imposter. His place in the academy had also been given to someone else. He then spent the next several years and most of his remaining money engaging in lawsuits against his family to get his property back, and it took the intervention of the king to get him reinstated in the academy. In 1789 came the revolution, when France became a distinctly unhealthy place for the aristocracy. But Le Gentil escaped the fate of many of his peers only because he died of natural causes in 1792, just before the Reign of Terror began. I can empathise with poor Le Gentil. In 2012, I might have set an unenviable record among British astronomers for travelling the greatest distance to not see that year's transit of Venus. I went 6,000 miles to Thailand, where on the day I saw precisely nothing and got very wet. But my journey there only took 18 hours instead of several months. So that concludes our trip through some of the oddities of astronomical history. As in so many fields, the truth is often much stranger than fiction. And in some cases, the truth is so bizarre that you really couldn't make it up. That's that. Thank you.
Neil, thanks very much for a very entertaining evening. And we're at that point of questions and answers. So, as usual, ladies and gentlemen, if you have a question online, can you put up a digital hand? If you have a question in the room, wave at Roy. So, in the 20th century, did you come across anything as Wiki was known as a difficult character? Who was his arch nemesis?
I don't think he had any particular nemesis. He just didn't get on with anybody, basically. He was a grumpy old git, and a lot of people found him difficult to work with. He was an absolute genius, but he was also a grumpy old git, and people found him difficult to work with.
But the 20th century didn't throw a penny any couples like the ones we've talked about?
Not that I know of.
Okay. So, questions? Roy?
Well, it's more of an asterisk to your unpleasant astronomers. I believe Tycho Brahe in the preface forward to one of his books about the nova, because everybody thought the nova was atmospheric effect or this and he wrote something. My recollection is it was something on the lines of, "Oh, you thick-wits, you blind watchers of the sky." And he didn't get on with many people. Apparently.
I didn't know that. Of course, the reason that Galileo got into trouble with the church was because he wasn't known for his tact and got up people's noses. I mean, it's commonly said that he was condemned by the church for teaching that the Earth orbits the sun, but it's not true at all. He didn't get into trouble for what he taught, but the way he went about it. He was certainly not known for his tact, and
it's got to be said that he did lead himself nearly to the stake. He was given the opportunity by the Pope Galileo to write a book to explain his ideas.
Yeah.
And he used the opportunity to cast the Pope in very poor light.
Yeah, well, he basically called the Pope a simpleton.
Yeah, well, and so yeah, I'm disappointed that was the outcome, but it's not really surprising.
Galileo basically got up the noses of all powerful people.
Certainly did. Mick Nichols online. Mick, over to you.
Yeah. Is it true that, bearing in mind he was the world's unluckiest astronomer, that Gentile actually built a camp on top of 5 tons of gunpowder? Because if that's the case, being so unlucky, if he invited you, you wouldn't go for tea, would you?
I haven't heard of that.
Apparently,
it wasn't that unlucky.
It was there. He built a camp on top of it.
I haven't heard that one.
Questions? Any comments? Tony Morris in the room.
This week, there was an article a long time ago, Sky Telescope, I think it was, and it was sort of his family members rebuffing the state of people's memories of Zwickau. They said it was easy to get on with it, but more or less he was very adamant in his professional beliefs.
Well, yeah, there's always two sides to every coin.
Yeah, that's the fancy. That's the thing.
I'm looking around for any comments. I'm trying to think of. Oh, 1960s Yorkshire astronomer. Fred Hoyle. That he had a long standing argument. I can't remember who it was with. Yeah.
Big facts.
A big fact.
Well,
Yeah.
Fred Hoyle actually invented the term Big Bang. And he invented it as a derogatory term for the theory he didn't agree with, but for some reason it caught on.
Up to the way. Hold it. Graham in the room.
Just as a very technical, quibbly sort of point, you've got that nice illustration there of Messier's catalogue, where he puts the right ascension and declination of all his objects very precisely. How do you think they worked out right ascensions and declinations if Messier only had a 4-inch refractor, which presumably didn't have a very fancy mount? I can understand someone with a big observatory and quadrants and stuff doing this, but how do you think he worked it out?
Good question. And the honest answer is I don't know. As you say, it would have been a fairly crude mount, certainly not an equatorial mount, because they hadn't been invented then. Weren't invented till 1820s. Yeah.
Who's to say that Messier didn't have a quadrant? Yeah.
Right.
Yeah. Thank you. Thank you for that from our observations officer. Mick Nichols again.
Hiya. I mentioned in Tycho, we know that he lost his nose in a duel. Was that with another astronomer?
Don't think so. It was only assumed.
I think the story is with Tycho losing his nose. It was a drunken dare, and it was a sword fight in the cellar in the dark. So, you know, big swords, dark room. What could go wrong?
Well,
It's
the drunken part
Well,
was
and the drink.
his character. He was known for liking a drink, wasn't he?
It was. So I believe that's the story, mate. That's the tale. I'm looking around for any other questions, comments.
About the transit of Venus, so people members in this room have seen both of them in this current apparition, so.
All right.
We're more lucky.
All right. All right.
Yeah. Well, I couldn't afford to go to Hawaii.
So,
Well, I couldn't afford to go to Hawaii and Australia for the eclipse in the same year. So I went to Thailand, which was a compromise between suitability and affordability. Well, yes, anywhere in Southeast Asia, basically the weather prospects were equally crap all over Southeast Asia. But the reason I went to the particular place in Thailand was, as I said, I had a lady there.
ladies and gentlemen, will you join with me in giving Neil Haggath a big Mexican Swinton Astronomical Society? Thank you. Thank you very much, Neil.